Okay, let's do this. So, today we're going to be talking about simplifying simple exponential expressions. These things take only 1 or 2 steps until you get to a final solution, so really it's not that hard. Now, in order to do this, you are going to have to be familiar with the properties that are listed for you on the screen right here, so either write them down, screenshot them, just remember them somehow because I'm not going to come back up to them. Like I said, this is a pretty simple situation. All you're going to have to do is follow your nose, see what you can do, and then do it. Let's see what that looks like. So, we're going to rewrite the following using only radicals and positive exponents. In our first example, we have x to the fifth times x to the third, all to the -2. We see that we have like bases on the inside of the parentheses, which means that we're going to add our two exponents together, so we get x to the 5 plus 3 to the -2. Add those together, you get x to the 8th, and that's raised to the -2 power still. This is our distribution property, so we multiply the two exponents, which gives us x to the -16, but we didn't want negative exponents. We're going to take that negative, put it in the denominator. This is a direct translation of negative exponents property. Moving on, we see that we have a quotient on the inside of our parentheses, which means that we have to subtract our two exponents from one another. So we're going to get x to the 7 minus 4 raised to the 1/5. When we simplify on the inside, we're going to get x to the third to the 1/5 power. This is once again our distribution property, so we're going to multiply our two exponents, and this will give us x to the 3/5. Now, we can't use any fractional exponents because we were told to write in terms of radicals. It's either radicals or fractional exponents, not both. In either case, we can write our answer in one of two ways, either the 5th root of x cubed, or we can also write it as the 5th root of x, all by itself, like so, raised to the 3rd power. Both of these represent acceptable solutions to this simplification problem. And on to our final example. Notice how the greater exponent of x is located in the denominator. In a situation like this, we're still going to use the quotient property that we have listed up above, but since the higher exponent for x is located in the denominator, let's do our subtraction there. So we'll get 1 over x to the 9 minus 2, which will give us a final answer of 1 over x to the 7th. Whoa. So, that's all she wrote. Just remember that you're kind of following your nose here. See what you can do and then do it. That's that. You're going to have to use these skills on things that are a little bit more complicated, so don't take them for granted. Those properties that were listed up above are super duper important to you. You should know them, and I think I've said everything that I need to say, right? Okay. Thanks for coming. Is that it? Can I go? I'm freaking starving here, man.